Good day. The theme of our lecture today is a classification of defects in the crystalline structure. Today we will tell the new part of our course, the defects of crystalline structure. And of course we will begin from the classification. Here you can see the plan lecture, the first definition. Then we will tell about the structure insensitive and sensitive properties. And in conclusion of our lecture, we will tell about the classification defects and some words about the point defect. The physical properties of an ideal crystal is determined by its chemical composition, binding forces between particles, and the crystal symmetry. Other words, categories, its symmetry and symmetry classes. These properties are called structure insensitive. These include magnetic, optical properties, piezoelectric effect, etc. However, in real crystals, many properties depend largely not only on the type of crystal structure, but also on the defects of the structure, the frequency of valence and valence. These properties are called structural sensitive. This, for example, ionic and semiconductor electron conductivity, luminescence, flexibility, strength, color structure, etc. Structure sensitive properties depend on the structural defects during the crystal growth, the plastic deformation, diffusion, etc. Structure defects are caused by several reasons. Thermal vibrations of atoms, for example, then valence of the electron density, the impact of any radiation, temperature rise, and other processes. Structural defects by geometrical phases can be divided into the following types. The point defects. Point defects is in violation of the periodicity of isolated points on the lattice of 3 dimensions do not exceed one or more interatomic distances. Point defects are a vacancy, for example, the atoms in the interstices of the atoms are ion, sublattice impurities atoms. Linear defects, one-dimensional, other words, extended in one dimension. A violation of the periodicity extends to distances comparable to the size of the crystal, while in others it does not exceed several lattice parameters. Specific linear defects, dislocations. In addition, unstable linear defects may arise from the chains of point defects. The next type of defect, the surface. The surface defects extend in 2 dimensions at a distance comparable to the size of the crystal, and the third one makes up some of the parameters of the lattice. These are the twin plane and of course the green boundaries and block stacking. Subgreen boundaries can be belongs to this group too. And the finish, the last defect, the volume. The volume defects are the voids, pores, particles of another phase inclusions. So here you can see micropores, clusters of point defects, etc. Of course, we emphasize again that all these defects are produced during crystal growth or as a result of various influences and significantly affect the properties of the crystal. And now I want to tell some words about the point defect. Point defect is a version of the crystal structure whose dimensions in all three dimensions are commensurate with one or several interatomic distances. A point defect can be simple and complex structure. Simplest point defects are vacancies, you can see here, of an atom or ion in a lattice site, and interstitial atoms or ions which are located on the illegal place between the nodes. Interstitial atoms may be both its own and impurity. You can see here interstitial impurity, the red ball, and the blue ball, substitutional impurity. The formation energy of one vacancy is of the order 1 electron-volt, and for the interstitial atom is more, a few electron-volts. Vacancies can be obtained into a D vacancy, 3 vacancy, and vacancy tetrahedron. But these defects belongs to another group, the complicated point defects, and we will tell about them in the next lecture. Thank you. Bye.